All right, here's a video on how to do problem 13 on this practice test. We have a two variable, one linear, one nonlinear equation here, and we're going to have to try to solve this for one of the variables first. And again, we have these nonlinear and linear situations, or nonlinear and linear systems. I kind of think substitution right away, because to get this to be elimination, I have to square both sides, which is going to be a way bigger pain than trying to use substitution. So the first thing I'm going to do is I'm going to take this second equation here, because that one's nicer to work with, and I'm going to have that be y equals negative 2x plus 10. So just subtracting that negative 2x onto the other side here. And I apologize for the bad handwriting. I don't have my stylus with me here to do this. Okay. And so what I'm going to do next, now that I have this as y equals, I'm going to plug that in for the y into the original equation, or the top equation, I should say. So this is x squared plus negative 2x plus 10. Now that's squared, because that's y squared, equals 25. Okay? Now, I need to ultimately FOIL this. I can't distribute that exponent in. So that is negative 2x plus 10 times negative 2x plus 10. And that is 4x squared from the first terms minus 20x minus another 20x from the outside and the inside terms plus 100. So then when I actually combine my like terms here on this problem, this is x squared still from the outside plus 4x squared minus 40x, combining these two here, plus 100 equals 25. And then just reducing it one more time, combining like terms and bringing over the 25 so I can actually factor it. This is 5x squared minus 40x plus 75 equals 0. I got to factor this thing, which this is factorable as it is right now, but to make it life easier on myself, I'm going to take out a 5. So the 5 goes on the outside. This becomes x squared minus 8x plus 15 equals 0. And then working with this is much, much easier, because it's got to multiply to be 15, add up to be negative 8. The two numbers that do that are going to be negative 5 and negative 3. So this is 5, x minus 3, x minus 5 equals 0. I can set each equal to 0, so that's going to give me x equals 3 and x equals 5. I can just plug these back in then. It's probably best to just plug them back into the original equation, this second one here, and that is 2 times 3 plus y, it's not very good, y equals 10. That is 6 plus y equals 10, or y equals 4. So one of the answers here, that is going to be 3, 4. Plugging in the 5 here, that is 2 times 5 plus y equals 10. That's 10 plus y equals 10. Subtracting over 10, that's y equals 0. So that is 5, 0. Okay? These are my two solutions that I get from solving it, and I have my answer there. So again, when you see a linear and a nonlinear, think substitution, because elimination is very difficult when you have these squareds here.